You're watching MyIPS on MyINDY-TV 23, a free educational service provided by Circle City Broadcasting of Indianapolis. Here's what's coming up this hour. Get more information, special announcements, and weekly program schedules online at wishtv.com, and be sure to follow us on Facebook. Here's what's coming up next.
Hey second graders, Miss Cooks here. We are going to take a look at our math packets. Go ahead and grab your pencil, grab your extra paper, and let's get started. So our objective for today is I can add, subtract within 100s. Before we begin looking at our packets, let's go ahead and review some math strategies. One of the strategies that you'll be working with and that you might want to go ahead and write down if you don't have these memorized yet. So it's the ways to make 10. For instance, 0 plus 10 equals, I hope you're saying these at home, 4 plus 6 equals, 8 plus 2 equals. Those are our making 10 math facts. And you can see I used a 10 frame to help give you a picture of those math facts. 10 is such an important number. We have 10 fingers, we have 10 toes, 10 Oreos. I wish, right? So 10 also helps make adding and subtracting so much easier, and I'm gonna show you how. If we know our make 10 facts, we can use, if you want to open your packet to page 3 and look at question number 1. Question number 1 says 8 plus 2. If I look at my make 10 facts, 8 plus 2 equals, you guessed it, 10. What if I look at problem number 2, I see 8 plus 3. Well, all I'm doing is just adding one more. So what is 8 plus 3? 11. Absolutely. Fantastic job. So you're going to be responsible for the rest of those problems on that page. But before we get started on that extra practice, let's go ahead and turn to the next page, on page 4. So on page 4, we're going to use another strategy that Ms. Cook loves. It's the doubles facts. So let's go through them really quick. 1 plus 1 equals, 2 plus 2 equals, 3 plus 3 equals, 4 plus 4 equals, 5 plus 5 equals, 6 plus 6 equals, 7 plus 7 equals, 8 plus 8, 9 plus 9, and then we have 10 plus 10. Did you recognize a pattern here? Did you see that all of the sums are skip counting by 2s? All right, great job, guys. So let's look at our first problem. Our first problem, they gave us 4 plus 4. Well, I know my doubles fact now because Miss Cook just went over them. So 4 plus 4 equals 8. The next problem says 4 plus 5, and we're just adding one more. So 4 plus 5 equals 9. Good job, guys. Okay, so you're going to be responsible for the rest of that page. And let's move on to our very last strategy for today. It is called the counting on and making 10. We have two problems here. We have 12 minus 3 equals, I don't know yet. Then we have 3 plus, I don't know yet, equals 12. So when I'm doing these problems like this, I picture in my head a number bond. And that's what I've went ahead and written out for you. So my 12 is my whole. And then I have, one of my parts is 3. So I went ahead and wrote that in my number bond. And then I have a question mark here because I don't know that information yet. So I'm going to go ahead and do some problem solving to help me figure out what that other part is. And I like to use a number line. So this is my open number line and my starting point. My starting point is going to be my lesser number. So my lesser number is 3. So go ahead on your extra sheet of paper, make a number line. And all you're doing is drawing a line. Here's your start. I like to think of it as a race. And I'm trying to get to my finish line. What is my finish line number? It is 12. So go ahead and add those two numbers because that's the information we know already. Okay. Now, I have my starting point and I have my finishing points. I am going to use my 10 facts from earlier because I know that 3 plus something equals 10. Do you remember what number equals 3 plus something equals 10? It's 7. So I'm going to do one big hop to 3 plus 7 equals 10. Well, that was easy. Now I can just count up by ones. 7 plus 10 plus 1 equals 11. 11 plus 1 equals 12. And I'm there. I won. Yay! So, am I done yet? No. I have to figure out what I added to 3 to get to 12. So I added 7, 8, 9. So 3 plus 9 equals 12. So that must mean, now that I have my number bond, that must mean that 12 minus 3 equals 9. And there you have it. That's how we are going to continue to use these strategies that I just went over to finish those extra practice pages. Have a good day. Just remember, we miss you. Your teachers miss you. Stay safe. Be strong. We'll get through this together.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Hi, my name is Mr. Waldorf. I have been teaching for over 19 years and I love to teach math. I am now working for Great Minds and I'm excited to have the opportunity to work with you in your Eureka Math lessons. Let's go ahead and see what materials we will need for our lesson today. Today we will be doing 2nd grade Module 6, Lesson 1. The materials you will need today are 12 counters, and if you don't have the 2 color counters that you use in your classroom, that's okay. You can use any small object that you have at home that you can count and group with. Some objects might be beans or some small crackers, paper clips, maybe some small building blocks, whatever you might have that are small items that you can count and group would be perfect. You also will need your problem set, and if you do not have your book with you, you can ask an adult to help you go to greatminds.org and download the Lesson 1 problem set for Module 6. If you still can't get it online, that's okay. You can still follow along in the lesson with me and still learn. You also need a pencil to do the problem set. You can go ahead and pause this video and take a couple of minutes to gather all your materials that you need. And when you are ready to begin the lesson, press the play button again. Okay, we're ready to begin. For this first activity, I want you to just watch and answer my questions. Anytime I ask you a question, you can just answer it as if you were in a classroom with me. I'm going to group my counters together, and I want you to answer this question. Are my groups equal or unequal? My groups are equal because I have the same number in each group. Let's look at this by circling our groups. Sometimes it's maybe confusing to think about what a group looks like. I can circle these to see my groups. Each circle is a group, so I have 1, 2, 3 groups. And how many counters are in each group? 1, 2, 1, 2, 1, 2. I have 3 groups of 2 counters. Read that statement with me. Ready, go. There are 3 groups of 2 counters. Excellent. Let's look at these counters grouped a different way. This time, I'm going to put 2 groups that look like this. So again, I'm going to circle my groups so you can see them easily. Here's 1 group and 2 groups. Now answer my question again. Are my groups equal or unequal? This time my groups are unequal. Remember, equal means the same. In this group I have 4 counters, and in this group I have 2 counters. They are not equal. They are not the same. How could I make these 2 groups equal? Since this group has more counters than this group, I can move 1 counter over to this group and see if I now have equal groups. How many counters do I have in this group? 1, 2, 3. And how many in this group? 1, 2, 3. So now let's rewrite our numbers in our sentence. There are how many groups? 1, 2. There are 2 groups of 1, 2, 3, 1, 2, 3. 2 groups of 3 counters, or 2 groups with 3 counters in each group. Read that with me again. Ready, go. There are 2 groups of 3 counters. Now that we've seen the activity that we are going to be doing, I want you to join me now by getting 8 counters in your workspace. Get 8 counters, and I will do the same. All right, now that you have your 8 counters, go ahead and put your counters into groups of 2, just like we did with the 6 counters. Now it's okay if your groups are turned a different direction. If your groups look like this, that's okay as well, as long as they're grouped together. Now, do we have equal groups? Our groups are equal because we have 2 in each group. Again, if I have trouble seeing what my groups are, I can circle them. How many groups or how many circles do we have? We have 1, 2, 3, 4 groups. And how many counters are in each group? This time there are 2 counters in each group. So let's read our sentence together. Ready, go. There are 4 groups of 2 counters. Can I group these differently? I'm going to go ahead and erase these circles that show my groups, and I want you to think about if I can group these in a different way. What if I could put 4 together? If I have a group of 2 and a group of 2, if I put those 2 together, and I put these 2 together, now what do I have? I have 1 group. I'm just going to underline them this time. I have 1 group in 2 groups. How many groups do I have? 2 groups. And how many is in each group? 1, 2, 3, 4. 1, 2, 3, 4. We have 2 groups of 4 counters. Let's read that together. Ready, go. There are 2 groups of 4 counters. How many counters is this in all? 2 groups of 4 counters is 8 counters. Okay, we've done 6 counters and 8 counters. This time I want you to get all 12 of your counters in your workspace, and let's work with all 12. So go ahead and take a moment to get all 12 counters while I get mine. This time I want to challenge you. I want you to decide how many are going to go in each group. You can pause the video now, group your objects, and then press play when you're ready to resume. So how many did you put in each of your groups? And how many groups did you have? Can you fill in this sentence with your number of groups and the number of counters in each group, and then read that sentence? One way you might have done it is, I'm going to do groups of 3. Now you might have done different groups, and that's okay. We've been doing groups of 2. I'm going to try groups of 3. Are my groups equal? My groups are equal. I have 1, 2, 3, 4 groups. How many counters are in each group? There are 3 counters in each group. Let's read this together. Ready, go. There are 4 groups of 3 counters. All right, now try and group your counters differently. So whatever you chose to do as your equal groups this time, choose a different number of counters in your equal groups this time. You can pause the video for some work time and then press play when you're ready to resume. Okay, I'm going to regroup mine as well. I have 3 in each group right now. I'm going to see if I can regroup this into 3 groups. Right now I have 4 groups. I only want to choose 3 groups now. So I'm going to take these counters and I'm going to see if I can share them equally with these other groups. Do I have equal groups? I sure do. I have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 in each group. How many groups do I have now? I now have 3 groups. I did have 4. Now I have 3 groups. How many counters are in each group now? Now there are 4 counters in each group. So I have 1 group of 4, 2 groups of 4, 3 groups of 4 is 12 counters. Excellent work. You can pause the video and try it even one more way if you want to. When you're ready to resume, press play. Did you try another way? How many did you get in each group this time, and how many groups do you have? And can you fill in this sentence with your groups and your counters? Well, nice work. We have seen groups of 2 and 3 and 4. I'm going to show that I can even make groups of 6. So if I take this group and move it to these 2 groups, now instead of having 3 groups, I have 2 groups of 6 counters. So there's 1 group, there's 2 groups. Now I have 2 groups of 6 counters. So that's even another way you could have organized your counters into equal groups. Now that we have seen many ways that we can group these counters, let's go ahead and work on our problem set. Pause the video, get your problem set ready, clear your workspace except for your problem set and a pencil. And again, if you do not have your problem set, then you can just continue watching and we'll do the problem set together on my paper. Okay, we are ready to start the problem set. We will do some of these problems together, but not all of them. Let's go ahead and start with number 1. Number 1 says to circle groups of 2 apples. I see groups of 2. If you have your problem set, go ahead and circle groups of 2 while I circle groups of 2. Now, it did not say 2 groups, it said groups of 2. So I have circled groups of 2. And the sentence afterwards says there are blank groups of 2 apples. How many groups do we have? We have 1, 2, 3, 4, 5 groups of 2 apples. I will let you do number 2 on your own at a later time. Let's go to number 3. Number 3 says to redraw the 12 oranges into 4 equal groups. I see that I have lots of oranges here and I have 4 groups. I don't know how many is going to go in each group, so I'm going to take one orange at a time and draw it into each of these groups. So I'm going to start with the first orange in the first group, second orange in the second group, third orange in the third group, fourth orange in the fourth group. Right now I have 4 groups with 1 orange in each group. Let's now do that with the next oranges. 1 orange, 2 oranges, 3 oranges, 4 oranges. So there's 1 more orange in each group, and I still have some oranges left. 1 orange, 2 oranges, 3 oranges, 4 oranges. I've used all of my oranges, and I see that I have 3 oranges in each group. So I have 4 groups of how many oranges? 4 groups of 3 oranges. We can also easily see that if we circle these groups here. We have a group of 3, group of 3, group of 3, and group of 3. Now our next problem says to redraw the 12 oranges into 3 equal groups. Just like we did with our counters, let's try and regroup these. I'm going to keep the first 3 groups the same. So I have 1 group of 3, 2 groups of 3, 3 groups of 3. So I'm going to draw 1 group of 3, 2 groups of 3, 3 groups of 3. So I've used these 3 groups. You go ahead and do the same as well. Now I have these extra 3 oranges. How can I put them into these 3 groups? I can put 1 orange in each group since there are 3 oranges. So the first orange goes in the first group, the second orange goes in the second group, and the third orange goes in the third group. Have we used all of our oranges? We have used all of our oranges. So now we have 1 group of 4, 2 groups of 4, 3 groups of 4. Are our groups equal? Our groups are equal, and now there are 3 groups of how many oranges? 3 groups of 4 oranges. Let's go ahead and do one more problem. I will let you do problem 5 on your own at a later time. Let's go ahead and look at problem 6. The same thing we just did with the oranges, we're now going to do with the lemons. We're going to redraw the lemons to make 2 equal size groups. So I have all these groups of lemons, and I'm going to make them into 2 groups. So right now I have 1, 2, 3, 4, 5 groups of 4 lemons. I'm going to start by sharing each group with each of these other 2 groups. So my first group of 4 lemons, I'm going to draw in my first group down here. My second group of lemons, I'm going to draw in the second group. What can I do next? Do I have enough to share another group with each of these 2 groups down here? I do, so I'm going to share this group with the first group down here, and this group with this group down here. Now I still have 4 lemons left. How can I share them equally with these 2 groups? I could go 1 lemon at a time, or I see that I have a group of 2 and a group of 2. So I'm going to add a group of 2 and a group of 2. That is all of my lemons. What do you notice about the lemons now in these 2 groups down below? I notice that they are in 5 groups. So I have 5 and 5, which is 10, and 5 and 5, which is 10. So I have 2 groups of how many lemons? 2 groups of 10 lemons. How many lemons is that in all? Well, I have 10 here and 10 here, so I could say 10 plus 10, which is how many lemons? That is 20 lemons. Excellent work on the problem set. Let's look back at one problem. I want to ask you a question about numbers 3 and 4. What do you notice about the number of groups and the number of oranges in number 3 and in number 4? I notice that I have 4 groups of 3 and then 3 groups of 4. The numbers are the same, they have just changed places. I also know that in this one I had 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 oranges. So I had 12 in this group. Did I change the number of groups? Did I change the number of oranges in the groups down here? I have 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, I have 12 oranges. So I could say 4 groups of 3 oranges is the same as 3 groups of 4 oranges. Excellent work today on our first lesson. Ask an adult to help you gather the following materials. You'll need your application problem. And even if you don't have your application problem, that is fine. Just get paper and pencil for you to follow along with the problem as we look at it on the document camera. Go ahead and pause the video and get whatever materials you need to complete this application problem with me. Okay, let's begin by reading the application problem. The problem says, Julissa has 12 stuffed animals. She wants to put the same number of animals in each of her 3 baskets. Let's think about that problem. Explain in your own words what is happening in this problem. Something you might say is that Julissa has 12 stuffed animals and she's putting them into some baskets. And she wants the same number in each of those baskets. Now let's look at what the problem is asking us to do. It says to draw a picture to show how she can put the animals into 3 equal groups. How many equal groups is she wanting to put them in? 3 equal groups. Now let's think about our lesson when we talked about equal groups. One thing we can do to show equal groups is to draw circles for our groups. So let's go ahead and draw 3 circles. Whatever I draw, you draw on your paper as well. Now that we have our 3 groups, which represent our 3 baskets, what can we do with her stuffed animals? How many stuffed animals does she have? She has 12 stuffed animals. And we're going to put them equally into these baskets. If I don't know how many go in each of these baskets, one thing I can do is draw those 12 stuffed animals so that I can put those in the baskets like we did in the problem set. Let's go ahead and draw 12 circles to represent her 12 stuffed animals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just like in our problem set, we can now share these with these different baskets and cross them off as we do it. So we have 1, 2, 3. That's 1 in each group. 4, 5, 6. That's 2 in each group. 7, 8, 9. Now we have 3 in each group. 10, 11, 12. How many do we have now in each basket? We can see that we have 3, baskets with 1, 2, 3, 4 in each basket. Let's now look at our sentence that we're going to complete for our application problem. It says to complete the sentence, Jaleesa put blank animals in each basket. How many animals did she put in each basket? 1, 2, 3, 4 animals in each basket.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Hi third grade friends, and welcome to grade 3 module 5 lesson 1. My name is Miss Roos, and I taught in Pasco County Schools in Florida for 9 years. My favorite subject to teach was always math, so now I work with Great Minds. And while we're out of school, Great Minds is doing everything we can to make sure we are supporting building knowledge on the go. I'm really excited to teach you some Eureka math lessons. Make sure you tell your teacher you're participating in this program so they know that you're still learning. Let's go ahead and get started. Here are some of the materials you'll need for today. First, you'll need paper cut into 2 strips. Make sure you ask an adult before you use any scissors. You'll also need a pencil and the lesson 1 problem set. If you didn't bring your book home, it's okay. You can go to greatminds.org and look up grade 3 module 5 lesson 1 to print the problem set. If you can't print the problem set, don't worry. I'll put it on the screen and you can answer the questions using a blank piece of paper. If you can't find all these materials, it's not a problem. You can watch me and we'll learn together. Here are my 2 strips of paper. To make these, all I did was take a normal piece of paper and turn it this way and then cut across to make 2 strips. I'm going to put one of these strips to the side for now. And let's just look at this one to start. Go ahead and fold this strip just like I do. When you open it up, you'll see 2 equal parts. The fractional unit for 2 equal parts is called halves. I want you to imagine that you have a classmate sitting right next to you, and when you answer this next question, go ahead and answer it aloud, okay? Let's think about what fraction of this whole strip of paper is one of these parts. What fraction of this whole strip of paper is one of these parts? Go ahead and say your answer. Maybe you said 1/2. And that's great thinking. If I told you that these 2 pieces were called halves, then one of them is 1/2. Let's go ahead and count our halves. We have 1/2, 2 halves. How can we prove that these are equal? Well, you may be thinking, if we had a ruler, we could measure them. We could measure this half and this half. And if they were the same measurement, then we could say they're equal. We also can say they're equal because when we fold, we see that there's no part hanging over here. So now that we have our fraction strip folded one more time, let's fold it again. Before we open up, think to yourself, how many equal pieces do I have now? Let's see if you're right. Now we have, take my marker and show you, 1, 2, 3, 4 equal pieces. The fractional unit for 4 equal pieces is called fourths. Let's do like we did before and let's count our fourths. Count with me. Ready? 1/4, 2/4, 3/4, 4/4. Okay, let's use our other fraction strip now. Okay, we're going to fold this one, but this one gets a little tricky, so make sure you watch me, okay? We're going to make an S, and then we're going to bring our pieces together and smush them so they fold. I wonder how many equal pieces we'll have this time. What do you think? Okay, let's see. All right. How many equal pieces did we make this time? I see 3. I see 1, 2, 3 equal pieces. The fractional unit for 3 equal pieces is called thirds. Let's go ahead and count our thirds. 1/3, 2/3, 3/3. Okay, let's fold them up and let's make one more fold. Say out loud how many equal pieces you think we're going to have when we open our strip up. Okay, third graders, let's see if you're right. Let's see. Count your equal pieces. The fractional unit for 6 equal pieces is called sixths. Let's count our sixths. 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. Awesome job with your fraction strips. Let's take both of them now, the one we made earlier and the one we just made, and let's take a look at them. Do you notice a relationship between how we made halves first, and then we made fourths, and then here we made thirds, and then we made sixths? I'm thinking back to multiplication, and I know a relationship between 2 and 4, 3 and 6. Say that relationship that you think of out loud. Maybe you were thinking about repeated addition. 3 plus 3 gives me 6. Or maybe you were thinking about multiplication. 2 times 2 gives me 4. Great thinking, third graders. Let's take a look at another way that we can see fractions in our world. Here I have 2 of the same size cups. Notice I put a little mark on the cup on the right. That's going to be really important later. Then I filled water to the line that I made on the cup. After I did that, I poured the water from the cup on the right into the cup on the left. And then I marked where the water came to with a marker. Then I filled the right cup up again. I see something very interesting here. I see that I have two equal parts. Then I poured the water from the right cup into the left cup. And again, I made a mark where the water came to. Then I emptied the cup, so all I had were these two marks. Let's take a look at this picture here, the one without the water in it. This cup shows something interesting. What is this line telling us? Maybe you said this was after she poured the water in 2 times. Or maybe you said this was the whole amount of water that she poured. Both of those would be correct. So then if that's our whole, what does this line represent? Maybe you said one of the 2 pieces, or 1/2 of the water. Great thinking, 3rd graders. Let's take a look now at 2 different pictures. Here we have the picture we were just looking at, and here we have a strip of paper, like the activity we did before. I want you to think out loud and answer. How are these 2 pictures the same, and how are they different? Maybe you are thinking about the fact that they're the same because they both have 2 equal pieces. Here on the strip we can see 1, 2, and here we can see 1, 2. That's excellent. Maybe you even use that fractional unit language of saying they both show halves. But how are they different? This was kind of a tough one. I was thinking that our whole in the strip of paper was the whole strip of paper, and then we had our halves. But our whole here is different. It's not the whole cup. What is our whole in the cup picture? Maybe you're thinking that top line is our whole, and that would be a perfect thought.
Hello everyone, and welcome to our fluency activity for 3rd grade, Module 5, Lesson 1. My name is Miss Chin, and I'm a former 3rd grade teacher from Chicago Public Schools. So I'm very excited to be here with you today virtually as we still experience our fluency activity from Lesson 1. So to get our brains awake and thinking about math, we're going to start by counting up by 4s up to 40. So I'm going to write our number and I ask that you count with me. Ready? We begin with 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. Excellent. Let's use our written model to help us count backwards. We're going to start with 40 and end on 4. 40, 36, 32, 28, 24, 20, 16, 12, 8, and 4. Thank you for counting with me. Let's count up again by 4, starting on 4. And when we reach 40, we'll count backwards. Go ahead and count with me. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. Excellent. And let's count backwards. 40, 36, 32, 28, 24, 20, 16, 12, 8, and 4. Excellent. Now I want to underline all of our numbers that are multiples of 8. So what numbers would I be counting if I wanted to count by 8? Well, I know I would start with 8. What is 8 more than 8? I bet some of you are thinking 16. What is 8 more than 16? Maybe some of us counted up to 24. What is 8 more than 24? That brings us to 32. And what is 8 more than 32? That brings us to 40. So now we're going to count by 8 up to 40 and then back down to 8. So use our underlined numbers if we get stuck. Go ahead and count with me. We're going to start with 8, 16, 24, 32, and 40. Excellent. Let's count back down. 40, 32, 24, 16, and 8. Thank you for counting. Now for our last fluency activity for this lesson, we're going to practice our multiplication facts. So you may choose to either write this with me on a scratch piece of paper or simply watch my whiteboard to guide your thinking. We're going to start with, let's do 2 times 4. What is the product of 2 times 4? Some of you may have said 8. Let's try another multiplication sentence. What about 3 times 4? What is the product of 3 times 4? Some of you may have said 12. Let's try another one. 4 times 4. What is the product of 4 times 4? 4 times 4 is 16. Let's do one more before we switch up some factors. 5 times 4. What is the product of 5 times 4? Some of you may have said 20. Let's try a few more. 2 times 8. What is 2 times 8? Some of you may have said 16. What about 3 times 8? What is the product of 3 times 8? 3 times 8 is 24. What about 4 times 8? Some of you may have said 32. And let's finish off our multiplication today with 5 times 8. What is 5 times 8? Some of you may have said 5 times 8 equals 40. So now I want you to pretend that you have a classmate next to you. And I want you to tell that pretend classmate, what patterns do you see happening between our multiplication sentences? One pattern we may have noticed is that each of these sentences begin with the same factors. So we first begin multiplying by 2, 3, 4, and 5. Some of you may have noticed that when we started, we only multiplied by 4, and then we challenged ourselves to only multiply by 8. Did anyone see a connection between our products when we changed from multiplying by 4 to multiplying by 8? Did anyone see a pattern when we changed from multiplying by 4 to multiplying by 8? What connections do we see in those products? Maybe some of us noticed that our products now double. 24 is a double of 12. 16 is a double of 8. And that's because when we change our factors from 4 and double it to 8, our products double too.
I'm Mr. Moses, coming to you from Charlotte, North Carolina, where I was a teacher for 8 years. I now work for Great Minds, and I'm going to be working with you while schools are closed on your application problems from Eureka math lessons. Today, we're going to begin with the application from Grade 3, Module 5, Lesson 1. The materials we're going to need for today's application problem are the application problem pages if you have them, or a blank sheet of paper will do, a pencil. We're going to be using a ruler with both inches and centimeters. It's very possible you don't have a ruler with both inches and centimeters at home. That's okay. You can watch what I do on my camera and still do the mathematical thinking that we want to get through this application problem, and then 2 other things to measure with that ruler. All right, so today, Grade 3, Module 5, Lesson 1 application problem. Every day we're going to be interacting with the read, draw, write strategy, which is we're going to read the problem. We're going to draw and label a model as we reread the problem in chunks. And then we're going to write equations when it's applicable. And then we're going to write statements to answer the questions we're being asked. Today we're not going to be writing any equations or expressions, but we will be writing some statements. So let's read the problem together. Measure the length of your math book using a ruler in inches. Then measure it again in centimeters. A. Which is a larger unit, an inch or a centimeter? Which would yield a greater number when measuring the math book, inches or centimeters? Measure at least 2 different items in both inches and centimeters. What did you notice? I'm going to switch over to my document camera now, where you're going to see the work that I'm doing and be able to follow along with me. Now would be a great time to grab that ruler and pencil and whatever you're writing on, and we're going to get started. All right, so let's start with A. Which is a larger unit, an inch or a centimeter? That's a great question, and you may already know because you're familiar with those units of measure, but we're going to draw a representation to show the size of those units. So grab your ruler if you have one. If not, follow along with me. Let's put that ruler down in this open section underneath A. And the first thing we're going to draw a representation of is an inch. I know that these are inches because my ruler says inch right here. I'm going to start by drawing my inch by making a mark at 0 and then another mark at 1 and drawing a line in between. If at any point I move too quickly, feel free to pause the video to catch up and then hit play again to keep rolling. Okay, so we just composed a unit called an inch. I'm going to go ahead and turn it into a rectangle so it looks like the tape diagrams we've been drawing all year. And I'm going to label this 1 inch because that rectangle is worth 1 inch. Now, this is a comparison type of problem. It says which is larger, which reminds me of the double tape diagrams we've been drawing since 1st grade. And I'm going to keep that idea up, and I'm going to just draw a line to help us to line up the beginning points of those 2 representations we're going to draw. We drew our inch, now we're going to draw a centimeter. So flip that ruler over I know it's centimeters because right here it says cm, which is an abbreviation for centimeters. I'm going to line this 0 up with that starting point I created with that line. And I'm going to mark where 1 centimeter comes to. It comes to there. I'm going to draw and turn that into a rectangle. And that rectangle represents the unit called 1 centimeter. So by looking at our representations, we can easily see which is a larger unit in inches. So let's write that statement. An inch is a larger unit than a centimeter. Go ahead and pause your video if you need a little bit more time to write that statement. I'm going to go ahead and move on to part B. B, which would yield a greater number when measuring the math book, inches or centimeters? Well, to really know that, let's go ahead and measure and see what we find out. Before we start to measure our math book, let's draw a representation of that math book. So here's that book. And we're going to be measuring how far across it is. So we're going to be measuring from here to here on that math book, and we'll record our thoughts back here as we measure. If you're using the page in your book, you're going to have to close your book and then reopen it back up. If you're using a loose sheet of paper, this will be a little bit easier. Let's go ahead and get that book ready though, and let's measure it. First with inches. So here's my book. We're going to measure it first with inches. I got to back my document camera up. All right. Let's go ahead and get that ruler out. Now I'm going to move my face out of the way so you can see the ruler. I'm going to move up to this corner here. All right. I'm going to line up that 0 with the beginning of the item I'm measuring, and then see how many units called an inch it is to get across this book. And I can see it's 1 inch, 2 inch, 3 inches, 4 inches, 5 inches, 6 inches, 7 inches, 8 inches. And it's in between 8 and 9 inches, which you're going to learn how to name that as a fractional value later. But for now, we're just going to say, it's about 8 inches. So let's return to our paper and label that when we measured this book, it was 8 inches across, about. Let's move that book back up again. Now let's measure it in centimeters. Flip that ruler around. Line up the 0 with the beginning of the item we're measuring. And then we're going to look at the end and see how many centimeters across it is. I'm not going to count because we're seeing this is in the 20s. I don't want to count all of those centimeters, but I know that there's 21 centimeters from the beginning to here, and then a little bit more. Looks like we have a fractional value again, which you're going to be learning about in this module. But for now, let's just say that this is about 21 of these things called centimeters. So this was 21 centimeters. So let's return to that question. Which would yield a greater number when measuring the math book, inches or centimeters? Well, it took 21 centimeters when it only took 8 inches, so it took more centimeters, or it yielded more centimeters. We're going to use the word took when we write. So it took more centimeters than inches. It took more centimeters than inches.
You've been watching MyIPS on MyINDY-TV 23, a free educational service provided by Circle City Broadcasting of Indianapolis. MyIPS airs weekday mornings from 8 a.m. to 10 a.m. For more information, special announcements, and the weekly program schedule, go to wishtv.com. You can also follow us on Facebook.